Hi everyone, so in this video we're going to go ahead and discuss some of the properties that make water so unique. So the first thing that makes water stand out from other molecules is its ability to form hydrogen bonds. In particular, it can form 4 different hydrogen bonds, which is a ton for such a small molecule. So each oxygen forms 2 hydrogen bonds, where the lone pairs on those oxygen would be, and then each hydrogen can also form a hydrogen bond. So because of this, water has very high intermolecular forces for its relative size. And if we look at this data, we see that normally as the molar mass increases, the boiling point and the melting point also increases. Now, water has a small molar mass, but its boiling point and its melting point is much, much higher compared to these other similar molecules. And this is because water has hydrogen bonding as well as London dispersion forces. The other molecules only have London dispersion forces, which are much, much weaker. So because of this, water molecules like to stick together, and it has a very high boiling point and melting point. Okay, so here are some quick reference point values for water. Make sure you particularly pay attention to the freezing point and the melting point of water, as well as the boiling or condensation point, and get those numbers into your memory because we're going to use them a whole lot. Okay, so water is also unique when it comes to its density. Most compounds are their most dense when they are in the solid form. Water, however, is most dense at 4 degrees Celsius, so slightly above its freezing point when it is still a liquid. And as it becomes a solid, it actually becomes less dense. That's because frozen water forms hexagons. It spreads out due to those 4 hydrogen bonds that it has, and those hexagons make the water less dense. Because of this, frozen water, ice, can float on top of water. Now, this is really, really important for several reasons. So, frozen ice floats on top of water. This allows aquatic life to survive in cold environments. If ice sank to the bottom, that would kill off all the fish in all the ponds and rivers that freeze over during the wintertime. Instead, they get a nice little buffer zone down below of the liquid water that is better insulated against the cold air. Now, one negative example of this is when it gets super cold outside, water expands when it freezes. So, if you lose electricity in your house, a common concern is that the pipes, your water pipes, might crack because the water inside them expands and takes up more room. Water also has something called a high specific heat, meaning it takes a lot of energy to raise its temperature 1 degree Celsius. So some examples that we see of this are swimming pools in either the early spring or late fall. So in the early spring, you might have a really warm day outside where it's like 85 degrees. But the water in your swimming pool, unless you have a heater, is going to seem really cold. That's because there hasn't been enough time for the water to absorb the heat from its surroundings and to warm up. But the good news is in the late fall, even if you have a cooler day outside, your pool will still stay nice and warm. Okay, so some other vocabulary words related to water are cohesion and adhesion. So cohesion is the attraction between 2 molecules of the same kind, so 2 water molecules. And adhesion is the attraction between 2 different molecules, so like between water and glass. Okay, capillary action involves both the ideas of cohesion and adhesion, and this is the ability of water to flow through narrow openings away from gravity, so it actually flows up. And this is important for things like trees because they need to get water from the roots all the way to their leaves at the tippy top. So this is due to the fact that water is going to be attracted to the material it's in, whether it is the part of the tree that the water flows in, or if it's glass or a straw or something like that. And when we look at the meniscus of water, so the very top surface of the water when it's in these small openings, it is curved up at the sides, okay? So it's concave meniscus. Its adhesion is greater than its cohesion, so it likes to bond with other surfaces more than it does with itself. This is in contrast to things like mercury that love to stick with other mercury atoms and don't want to go up small openings. Water also has a very high surface tension. This is because the water molecules do still like to combine together with those hydrogen bonds, so it has strong cohesion as well. So an example of this is water striders, those bugs that like to flock on top of water. They are able to do this because water has a high surface tension. This is also what allows us to float on top of water. Okay, so thanks for watching, everyone. I hope you enjoyed learning about some of the unique properties of water. If you have any questions, please go ahead and let me know. Bye.